This is lesson 3. I'm on page M139. Notice there are a lot of key terms that we're going to be talking about. This is kind of a long lesson, so just keep in mind that we will have quite a few vocabulary words going on here. So first thing, we're going to define a function as relation. We're going to write equations using function notation. That's the stuff that we're doing today. So I'm not going to do the getting started. I'm going to go to this 3.1, functions and non-functions. Functions and non-functions, sorry. A relation can be represented in the following ways. So notice you should be familiar with ordered pairs, the x, the y. An equation, you might have seen one like this in a previous year, but so that's an equation. Verbal, that's like a word problem that you would think of. Mapping, notice it's saying that 1 gives you 2 as the answer, or 2 is the y value. So these are actually the x values, and these are the y values. You should be familiar with graphs. You probably have never, well, recently you've seen graphs in my class that look like that U, but you've probably not seen very many U-shaped graphs. We will get to more on what those are later. Then we have a table. Okay, so I'm going to go ahead and I'm going to open my notebook and I'm going to start with some vocabulary words. So notice there are vocabulary words over here. I'm going to start writing those down in my notebook. Okay, so I'm going to zoom in. So we have domain. You might have seen that a few times on that page. So domain is the set of input values or the independent values. Okay, and we typically use it, or we represent as the x values. So remember, independent is x. Okay, then we have range. Ooh, that might be hard to see. Let me make it focus. Okay, so range is the opposite of domain. So domain is range. It's the set of output values or the dependent values. Sorry, my orange pen isn't going out. Okay, and it is represented, let me switch colors, see if it helps. Represented as the y values. So remember, y values, those are the dependent. Okay, so also in your notebook, I just want you to write a few examples of those things that we were just looking at. So we have ordered pairs, which would be something like, or is the xy coordinates. We have equation, which you'll also hear me call it symbolic on occasion. So an example of that would be like y equals 4x. I'm going to go over here and write a few more. Verbal or description. Also word. Might be something like $2 per shirt. And then of course we have a graph, which remember a graph has the y-axis and the x-axis, and we'll just make a U like they did. Okay, we had the mapping, where you'll see it with arrows. So you might have like 1, 2, 5, and then over here you might have 0, 3, 4. And those are just random numbers that I made up in my head as I was going. We have table. Which you have x and y, 2, 2, 4, 1, 5, 7. So x and y values. And then the last one was, did we get them all? Equation, ordered pair, verbal, graph, mapping, table. Yeah, I think I got them all. If not, I will see it in just a minute, of course, and then, but you could always just write it down. Okay, so what we're going to look at now is we're going to look at an example of a function. So an example of a function, and a function is when each domain, of course we just said that's x, has exactly one range value. And remember, range is y. Okay, so in order to be a function, and I'm gonna, so that you can see that, x cannot have two different y values. So if we were talking about like number of shirts, I can't say that one shirt is $5 and one shirt is $12. It's one or the other. So you wouldn't go to a store that said, well, sometimes for some people I charge this much and some people I charge this much. Of course, unless you're a worker, but you typically wouldn't want to go somewhere that, if you're blonde, because you guys know I'm blonde, if you're blonde, we're only going to charge you this much, but if you're have dark hair, then we're going to charge you this much. So that's kind of what it means, and we're going to look at that in just a second. So, and I want you to go ahead and put this note. Y values, I'm going to turn off my air conditioner so that it's not so loud. Y values can repeat, x can not. And I'm going to show you that in a table in just a second. Okay, so let's look at an example of a function. So an example of a function, so if we were doing ordered pairs, and I had the points -2, 2, -1, 3, 0, 2, 1, 5, and 2, 3. So we're going to do the function one on this side, function, and non-function on this side. So again, ordered pairs. Okay, there we go, my air conditioner turned off. So then the non-example I could use is -1, 4, -1, 5, 0, 2, -2, 3. Okay, so the thing that you are looking for every single time when you're doing these is that x values cannot repeat. So notice we have x values of -2, -1, 0, 1, and 2. None of those repeat. If you look at the non-example, -1 and -1 repeat. So that's why this is not a function. So you can go ahead and write that note if you want. Can not repeat x. Notice here we have a 3 and we have a 3. So y values can repeat, but x values cannot. Okay, let's go ahead and do a mapping one. And I'm going to use the same values each time just so that we're not getting new stuff every time. So notice I'm going to put my x values in this part of the map. So -2, -1, 0, 1, 2. And I'm going to put my y values. So 2, 3, 2, you don't write the repeated one in a map, and then 5. So -2 goes to 2, -1 goes to 3, 0 goes to 2, so I'm going to draw that arrow up there. 1 goes to 5, 2 goes to 3. So notice none of these arrows go to two different places. Watch the one for the non-example. We're going to use these values from up here. So I'm going to do -1, -1, I don't rewrite it, 0, and -2. Then I'm going to do 4, 5, 2, 3. And the order doesn't matter in mapping, just so you know. So -1 to 4, -1 also goes to 5, 0 goes to 2, -2 goes to 3. So this right here is what makes it a non-function. -1 repeated because there's an arrow going to two different numbers. Okay, let's look at the table. X, Y, you could also call it domain range. So -2, -1, -2, 2, -1, 3, 0, 2, 1, 5, 2, 3. I'm going to squeeze that in there because I need room for my graph. So then I'm going to use these same points, -1, 4, -1, 5, 0, 2, -2, 3. So again, there's a repeat in the X column. Notice there's a repeat in this Y, but we don't care about Y. All we care about is the X. No repeating X. This one has a repeating X. That's why this one's not a function. Okay, last part is our graph. Okay, so I'm going to take those points. Remember, it's x comma y. So I'm going to go over to -2. Oh no, I did not put my line in the middle. Goodness gracious. And I do not know where my whiteout is. Okay, so I'm just going to mark it because I was being silly. But so I'm going to go -1, negative 2. Man, I'm not happy with myself. I'm going to move up here so that I can do it properly so that no one gets confused. Okay, so we're going to move our graph up there. So I'm going to go negative 2, so 1, 2, up 2, 1, 2. I'm going to go negative 1, go up 1, 2, 3. I'm going to go 0, 2, 1, 2, 1, 5, 1, 1, 2, 3, 4, 5, and then 2, 3. 1, 2, 1, 2, 3. Okay. So if I was to connect those, which this is probably a discrete graph like we've talked about, but if I were to connect those, it just makes two of those V-shaped like that we kind of saw last week. I'm going to move this line to here, so ignore that one. Okay, so I'm going to go to negative 1. I'm going to do these values. So negative 1. I'm going to stop the video and white that out, and then I'll start the video again. Okay, so I whited it out. If you have whiteout, or for purposes of the video, I didn't turn to the back of the page, but you could also turn to the back of the page if you followed what I did. But, okay, so we're going to go negative 1, so negative 1, and then up to 4, 1, 2, 3, 4. I'm going to go negative 1, 5, so 1, 2, 3, 4, 5. 0, 2, so 0, 1, 2, and then negative 2, 1, 2, up 1, 2, 3. Okay, so if I tried to connect those, it would feel weird because I would have to go like this, and then straight up, and then straight back down, and then over. So the repeated x value, so notice this negative 1 right here is on the x-axis, so you cannot have a repeated x value there. So what we're actually going to call this, and it's our next definition, is the vertical line test. Okay. Sorry, that sounded like George of the Jungle. Okay, so here we're going to have vertical line test. So is a visual method used to determine if a graph is a function. So if we have a graph, I'm not going to make that mistake again where I don't use the lines. So this one, let me draw the non-function, and then I couldn't even. So if you notice, if I can draw a vertical line everywhere on the line that's drawn, so here's my vertical line. Notice if I slid this line along the whole thing, it would never hit in more than one place. But if I drew a vertical line here, it would hit in more than one place. As soon as it hits at least one time in more than one place, it makes it non-function. So that's what we call it when we're looking at a graph. You can use the vertical line test to say that this one's not a function and that this one is a function. So that was our big thing that we wanted to talk about today, was how to decide if something is a function or not a function. And really, you need to be able to remember all of the ways. So in an ordered pair, x cannot repeat. Mapping, you can't have an arrow that goes to 2. Table, X cannot repeat. Graph, X cannot repeat. Or the vertical line test.